production and the smart connectivity of this big data. And most probably you can see also the change on the next slides. There are more now solid pictures, which most of you know, a little bit more rocks or tunnels, and also maybe you see that I'm wearing a tie, so I'm not working in Silicon Valley. I'm based in Switzerland, which we are in the Geomamtic group. Good. I will structure a little bit my presentation. I'll give you a rough introduction about how we're dealing with the digitalization part in the Geomamtic group, which is engineering and technology, and then talking a little bit in the process on assessment, the design phase, and then also important, what I would like to have a discussion also, or point out, is about when you go from a design, from the clean office into the tunnel, into the dirt, the dust, what we can do there with digitalization, and what is there also the BIM part. And then I would like to talk about the two cycles inside tunneling. One is the geometry control as built, and one is also the geotechnical part. Maybe one word also to say, in these days, I'm now early 30s, but in my team, which I'm leading as a business unit manager in tunneling from Geomamtic Technology, we have now more than 80% are IT-related persons, so are working in-house the software development and are programmers and dealing with it. So this is definitely something about which is a big change also during the years that I'm working in that company. Good. The first thing I would like to talk is about the assessment. The BIM in the assessment phase is dealing already, you see on the left also the Scandinavian project picture. There will be a couple of pictures from Scandinavian. You see before we had Finnish person a lot here, but this is actually more now in the Scandinavian part of. But one thing on the assessment challenges here is, for example, in this project here, Tunnelbanan in Stockholm, that's an existing design or scan of a tunnel. In these days often done by, for example, mobile mapping. So you're scanning existing projects, and then based on this data, scanning data, you're doing a planning of your existing project, how they are connected to each other. Below you see a picture of a new system, a mobile mapping system adapted from Hamburg, which we integrated to getting this data with 30-40 kilometers per hour to get a good information about the existing project. And this helps to do the plannings for your tunnels in the BIM phase and in a completely 3D phase. The other topic on the right hand side is a little bit more related to geology. Geology is on one hand side beginning of the tunnel where we also get the connection about underground and above. So we need terra models, but also an important thing is about the geological data. The data you will get on many different sources in these days. You get it from catalogs, maps. Here an example on a tool which is based on seismic prediction. This is more doing construction where you can extract the fault zone in the 3D in the BIM software. This, everything you can put in the world, which you use then for your design phase planning of the BIM data. Good. Some couple of more examples here on another project in Scandinavia, Förbifart. Here you see why it's BIM was so important in the complete design phase. You see quite a lot of complex geometries, which are connected shafts to the terra model, to the above, but also shafts which are ventilation or installations which are connected to each other and to existing infrastructure, but also to other infrastructure types here. And the other thing is maybe also the big difference in the BIM world coming from the construction world or building above to underground. We're having a little bit of different geometries. We are not following rectangular areas so far, and also we're having different types of design axis. I mean, a design axis is one part you do your plannings, but during the construction you can also, a TBM drives another axis line, and during the construction we call it also often dynamic planning on changed on the axis. So this is something where you get a lot of things during the construction a lot of uncertainties on the site which has been changed, and that the 3D world and then the BIMs helps you a lot to do this implementation on the work site. Good. Some example also where BIM helps us in these days a lot in the design phase. The top left picture is an example on pipe roof umbrella where we want to calculate also how they fit to a pre-tension bolting there. And then you can easily run the BIM software these clashes, and you can see already in advance where these clashes are happening. And important thing during the design phase, this 3D geometry, you know then that there has been some impact, that you have to do some changes. Another example on the right hand side is you've got existing tunnels measured, scanned, and then you do your plannings. And below here you see the drainage system from the existing tunnel, and where does the drainage system comes in from the new tunnels. And this is something when you connect it to each other in these 3D models, they have a much more easier understanding, and you can easily decide and do a design on offering. You'll be more sure, and it helps you definitely for your plannings and doing your design phase. Collecting a lot of data. There are rigs, stores, logging, a lot of information. We have surveying data of the guidance, of the scanning, controlling. So after, for example, every advance, you're doing blasting, or we have geotechnical data, we have geology, we're having a lot of source of data, and this must become to one certain spot of a database, which then also important that this one will be stored in there, and that once it comes handover from the construction to the operation of the tunnel, that you also have this data available. One example here, which we're also dealing with in these days, is about when you're collecting big data inside a tunnel. In an example here of laser scanning, in these days it's quite often usual that you can directly process the data and that you not waste too much time. So you're collecting the data, this is directly processed, and you can directly, below in the picture you see an intersection between your 3D design model compared to a point cloud. And this was in the past possible in a couple of hours. Now you're talking about this data is available in real time. Real time means you can then touch directly, for example on a tablet, touch on this certain spot, and you directly mark this area on the tunnel wall.